Good morning, kids. Welcome back to the course of electromagnetic fields. And today we will be discussing about the concept of electric fields. As I have said to you in the last class, that electric fields are so important for electrical engineers, and we should be able to compute the electric fields. So, in today's class, we will be discussing about in detail about what do you mean by an electric charge, and what do you mean by electric currents, electric potential, and electrostatic force, and also electrostatic field. So I will give you a glimpse about all these quantities, and at the end we will see if there are any particular equations which link all these terms. Okay, I will start with the basic concepts of electric charge. The first thing is about electric charge. Now, as you all know that electric charge, just like a magnet will be having north and south poles. Similarly, electric charges also do exist. You might have seen in your chemistry that every material is basically made up of atoms, and atoms in turn consist of electrons and protons and neutrons, and electrons are negatively charged particles and protons are positively charged particles. Similarly, in electrical engineering, we do believe that the group of electrons, which are basically negatively charged particles, they are termed as a negative charge. So, we do assume that negative charges and positive charges do exist in this matter, and these charges, they produce electric field and also magnetic field. But let us confine ourselves to only electric field in this class. We are more concerned about these charges only right now. So, a charge basically is represented in this format. This is a positive charge and this is a negative charge. So, if you carefully see the positive charges and negative charges, if you take an atom, basically this is an atom, and you will be having positive charges and you will be having negative charges like this. You might say that the positive charges and negative charges, they will be in the form of, you might have studied in your chemistry that there will be a nucleus. Inside that you will be having positive charges, and around it you will be having electrons, right? So similarly, this is a mere representation that an atom just consists of positive and negatively charged particles. And these charges, if you carefully see, these positive charges and negative charges, if we feel that they do exist outside also apart from your atoms, if we do feel that we do have an individual negative charge and an individual positive charge, they are responsible for this electric fields. Okay, and charges are measured in terms of coulombs, as I've already shown to you. See, this is coulombs. We will represent it as C. So charges are measured in coulombs. Normally charges are of the order of basically nanocoulombs, or they might be of the order of microcoulombs. And as already I said, they can be of positive and negative, and they can exist individually. See, in the magnets basically you will be having north pole and south pole. At any time when there is a north pole, there automatically in the vicinity of that you will be having a south pole. But electric charges, we assume that they can exist individually. That means a negative charge can exist without the presence of positive charge around it. See, if we take this is north pole and south pole. Let us suppose if I cut this magnet, so immediately this one is separate magnet and this one is separate magnet. So again immediately you will be having N and S here, and again you will be having n and s. This is the concept of how our magnets do work. But whereas charges, they can exist. You can have a positive charge and you can have a negative charge individually. There is no relation between them. It is not just like a magnet where immediately north and south poles do exist. Okay. And having said this, now we will move on to different types of charge configurations. Now, assuming that the charges can exist individually, now let's get back to the different charge configurations. Charges, as I have already mentioned, they can be of isolated charges or what we call it as point charges, which means just like there is a charge like this one, a point charge. And they can be line charges also, where these line charges can be of this form. So this one is an entire charge basically. Let us suppose this is having an entire charge, a negative charge, or like this. There will be a positive charge along this line. So this type of charges are called as line charges. Now plane charges. Plane charges are two-dimensional charges. Let us suppose this is a dimension, plane dimension, a rectangular plate like type of thing. Now you can have this negative charges on this plate. This is plane charges basically, or you can have a positive charges. So these are the different types of charge configurations which you can have. And the next one is volume charges. Volume charges are basically three-dimensional charges, just like you can have a cylinder basically. And it may be having negative charges. Or you can have a spherical one. Okay, this is a spherical charge basically. Now, this is just like a ball which is full of positive charge. So, I will take this one as a positive spherical charge. So, these are the different types of charge configurations which we can have. And next is, having said that the different types of charge configurations, now we will move on to the electric currents. So electric current basically, see I have already shown you different types of charge configurations, right? Assuming that the charges are existing individually. Now these charges, let us suppose there is a charge which is present here. And there is assuming that these are all electrons basically. So each electron is basically a negative charge. So I am taking a wire here. And assuming that the electrons are passing through this one. I am representing this in this fashion. So assuming that the electrons are passing through this one. So the movement of charges is basically termed as current. Normally the charges which are freely available in nature are electrons. So that's why we have been considering as electric current is the rate of flow of electrons. And in particularly, we know that in your physics you might have studied there are different types of materials, and generally conductors are those materials which do allow the flow of current to pass. Which do allow the electrons to pass through them. So that's why I have written here. Electric current is the rate of flow of charges. Here charges are electrons and they flow in a conductor. And this is measured in terms of amperes, often represented as A. Okay, strictly speaking, the current which is flowing, it depends upon the amount of charge which you are allowing to pass through it. At the same time, the rate at which it passes. So, I is equal to dq by dt, which means this is called as a rate at which the charge passes through a conductor. So, this is the formula of the currents. Okay, and next, potential. Now potential, there are so many terms, so many definitions. So an easy thing, I'll make it easy for you. See, let us suppose I do have a box like this. Okay, assuming that this is let us suppose there is a charge which is present here, a negative charge. I will take it as an electron which is present here. Initially it is present here. So I want to move this one to at this position. Let us suppose I want to move to this position. See, there is a movement of charge, so that's why I can call it as a current. Now, in other terms, what I can say is nothing but to move this charge from one point, from this initial position to your final position, I do require some energy, right? So this energy which is required to move this point to this point is termed as electric potential. So that's why I have mentioned here clearly. See here, it is the amount of work or energy needed to move a unit of electric charge from a reference point to a specific point in an electric field. See, this is an electron. I am trying to move it to this place. So this amount of energy which is required to move this electron is called as an electric potential. Okay. So, and this electric potential is measured in terms of volts. It is measured in terms of volts. Okay. So that's it with this video lecture, and in this next video lecture we will be going through this electrostatic force and also electrostatic field.